Good morning, computer scientists. Happy Friday. Because it is the last day, before we get going, I'm going to ask a favor of you. Please don't start crying. If you start crying, I'll start crying. We'll never be able to get through this. Here are our last little batch of things, and again, folks are doing just a really spectacular job. You've seen a couple times that when, for example, like on this little airplane, you can't see it very well, but when things are built up off there, it has to make a little raft, so there'll be a lot to clean away from that there. And same with this little thing, I'm not even sure what that is. Okay, so cool. If one of these is yours, be sure to pick them up on the way out. And again, if you want a bigger one, different color, better one, we can do that. Now that I've gone through them all, let me know. So thank you for thinking a little bit about what you've learned in this class and giving me some feedback some way, either on that sheet or via the course evaluation online. That will be helpful to me. Thank you very much. Current events for today. We are going to be talking about artificial intelligence inside the First Church of Artificial Intelligence. If you think they're just putting us on, they're not. This is incorporated as a 501c3 religious organization in the state of California. Way of the Future, Anthony Lewandowski. We'll be talking about transhumanism and will computers become human. We're going to do that today. Some of you may recall the name Stephen Hawking. Before his death, Dr. Hawking was terrified of artificial intelligence. He says, unfortunately, it might be the last thing that humans do. The short-term impact of AI depends on who controls it. The long-term impact depends on whether it can be controlled at all. Interesting. So let's investigate some of these things. Oh, okay, little levity after that. Artificial intelligence is no match for natural stupidity. Okay, you can write now. Chuck Norris once took an entire bottle of sleeping pills. Made him blink. Okay, you got to stop now. So, very last topic that we'll investigate in CSC 150, Cap C under Roman numeral 3. Will computers think? Will computers be like people? Last time we looked at the origins of artificial intelligence. We also looked at one of the two major camps of artificial intelligence, and that's weak AI. Let me review the goal of weak AI, and let me give you a couple other examples. And we want to talk about an aspect of that because it'll be important for the other camp. So, weak AI, what's the goal of weak AI? The goal is to simulate intelligent behavior in a specific area. We encounter the fruits of AI all the time. If you use a mobile device and you speak to it and it somehow replies, Siri, Cortana, Hey Google, etc., then you're interacting with artificial intelligence, specifically weak AI. My wife is flying to Albuquerque, New Mexico in just a little bit to do something. And I wonder if she'll be on an autonomous airplane. This is an Airbus A380. Airbus is a French manufacturer of large commercial aircraft. The A380 has a fairly sophisticated avionics system. Avionics, don't remember that, just the software controlling a plane. This plane can do it all by itself. It can do everything without a pilot. There's only one task this plane cannot do, and that's back away from the gate. Planes don't have a reverse gear on them. They need a little truck, pushes them away. After that, this plane can do everything. If the pilots so choose, they can just go along for the ride. This is an example of weak AI. Is it real? You bet. Exists today? Absolutely. Now, let me use that as kind of a segue because I got to do one little interlude here so we can see the next type of artificial intelligence. When Chuck Norris gets in an elevator, the world goes down. Speaking of elevators, I'm not going to ask you to remember all the Zeb and Martha jokes that I told you, but if you do, Zeb was actually an elevator operator in one of my jokes. That was an actual career. That was an actual job. In the 1920s and 1930s, there were human beings that operated the elevator, made it go up and made it go down, etc. Do we have human beings operating elevators today? No. Okay. Now, what do you suppose? Put yourself in Zeb, the business person, or Martha, the business person's point of view. It's 1922, you go to work at the Chicago Mercantile Exchange, you always go up to the 5th floor, that's where, and you've been taking the elevator, and one day you walk in and there's a sign, elevator is automated. You have no clue what that word means, but you look inside for Zeb, the elevator operator, and he's not there. The sign says, push the button, it'll take you automatically to the floor you choose. What do you suppose people's reaction was? Well, I'll tell you. I'm not getting in that thing. Where's the elevator operator? I'm taking the stairs. Now, of course, depending upon how far up you had to walk each time, that lasted for a little bit of time. Right? Today, anybody here afraid to get into an elevator without an elevator operator? You'd be afraid if there was one. Right? Who are you? I'm the elevator operator. Okay. I just think. Funny how perspectives change, isn't it? Sounds funny, doesn't it? 30 years from now, when your children or grandchildren say, come on, Mom, come on, Dad, let's get on the airplane, and you ask, does this plane have a pilot? They will laugh riotously. When Chuck Norris takes the elevator from the 1st to the 10th floor, yeah, he carries it up the stairs. Folks, I want you to think through some things. All right. Now you're saying, autonomous airplanes, prayer meeting, skydivers on a practice run. Ever do that in the elevator? You know, it's going down. You don't do that? Dang. Last time we talked about autonomous vehicles. You see it enough in the news that you know this is a real thing. You know this is coming. You know that maybe even within my lifetime, and there's not a lot left, but certainly within your lifetime, there are going to be autonomous vehicles running all over the place. Right? Don't go, yeah. All righty? Good. Now you're saying, but, I've got some concerns. Okay, let's review. What do we know about 99.99% of all software applications? Airflow. Pardon me? Airflow. Yes. Bugs. Now, is there a difference between a bug controlling the avionics in an A380 and a bug in your word processor? Yes, there is. No question about it. It's a legitimate concern. The other concern is a topic that we mentioned briefly in Unit 3 after we did some programming. I mentioned that algorithms are powerful tools, but they are also inflexible. By that I mean they are not robust. Robust is a computer science term that means the ability to deal with the unexpected. Algorithms are powerful, but they are not robust. What if there was something unforeseen? What if in assignment 7, when you program the guard's weight, what if, I can't even imagine anything there. What if they typed in their height instead? You know? What if the problem changes? The algorithm can't deal with it. But realize these are the problems with current generation computer systems. So those are the problems that exist right now. Artificial intelligence hopes to do something. And one of the things that researchers hope to do is to replace algorithms, which is today how computers solve problems, really powerful tools to solve problems, but replace them with heuristics. Heuristics, that's how people solve problems. So rather than just having computers blindly follow instructions, can we get computers to think and reason and comprehend and understand and learn? Well, if we could do that, would computers be better problem-solving tools? Absolutely, because that's how we do it. So that's the point. So don't be afraid of the elevator. You're not, okay? When the cars come, just don't make me do it. Is that okay? When you're the decision maker, please don't make me do that. I like to drive. I want to drive. Autonomous vehicles on the racetrack? I can't hardly wait for this. You know, let's go see the races at Road America. Come on. All right, here's my segue into the last major topic and the one that several people asked about. I call it strong AI. I'll give you a definition in a minute. There's another term I'll show you too. This is a Newsweek magazine. It's an actual magazine. Have you seen magazines before? This is 21 years old this month. You see the human being there at the time, that's Garry Kasparov. He was the world's best chess player, world chess champion, the best chess player on planet Earth. Man versus machine, the rematch, the brain's last stand. 22 years ago, Garry Kasparov played a celebrated chess match against an IBM supercomputer, and he won. This is the next year, the rematch. You want to guess what happened? He lost. For the last 21 years, the best chess-playing things on planet Earth have been computers, not human beings. Now, that may bother you. Don't bother me at all. I don't like chess. So, I had two people ask for this. One actually used the term. I'm not going to ask you to remember the term because transhumanism is a fairly new term and lots of different people define it in different ways. I'm going to use a different term, strong AI. But you'll see transhumanism used often, like in the Church of Artificial Intelligence. So let's talk about that. However, I'm just going to call it this, strong AI. So 2 was weak AI, 3, strong AI. Rather than cutting back on what we think computers can do vis-a-vis human problem solving and intelligence, strong AI says, oh, the sky's the limit. As a matter of fact, even more than the sky's the limit. Here's the basic objective of strong AI. Create thinking machines via human equivalence. Create thinking machines via human equivalence. I want to take this and break it up into 2 parts because I really believe most people shove these together, but I believe they are really separate and actually have different answers for the different pieces. So, great. Thinking, well, I mean, just intelligent, you know, rather than machines, we'd say computers. AI researchers, for historic reasons, talk about thinking machines rather than intelligent computers. It's just the term that's been used. So, I'm going to break it in half. Question 1, can computers be intelligent? Last week I shared with you that most people think computers are intelligent, and it's absolutely true that computers appear intelligent. So question, can they really be intelligent? Well, let's approach this the way the computer scientists would approach it. Let's think in terms of problem solving. This is a problem, right? Let's think about this in terms of problem solving in computer science. Oh, let's review. What's the first step in problem solving? That's it. Have you been reviewing, Ben? Good for you. Understand the problem. The first step is to understand the problem. You don't understand the problem? Can you solve it? No way. All right. So we got a word problem here. Can computers be intelligent? I think what we have to do is focus on the key word in that question. And the key word is intelligent. Hi. Where do I go to take the intelligence test? The key word in that question, remember what was the question? We know what computers are. Can computers be intelligent? To answer that question, you have to tell me what intelligence is, the definition of the word, what it means. Otherwise, how do I know? So let's do that. Folks, this is actually a topic that we should legitimately spend a week on. We're going to spend 5 minutes. So I'll ask you to read a little bit more about it if you're interested, but otherwise just play along with me. So what does intelligent mean? Early this week I told you, you are all intelligent. Sign up to be a person. Thank you, Luke. Then we are intelligent, right? Good. Comment, question.
Yeah, I thought you were going to ask my intelligence.
Are you going to do that?
I could.
Good. Go.
It's the...
Don't look at that.
It's the ability to differentiate between poor instructions and good instructions.
Wow. That's pretty interesting. The ability to differentiate between poor instructions and good instructions. Imagine if the computers could do that. We can. Imagine the computers could. That's a good definition. Let me show, see the problem with that one though is it's over in 2 minutes. I said it'd take a week. You didn't believe me, did you? If you ask folks who actually spend time investigating this, there are several different approaches to trying to define intelligence. One is to list attributes or characteristics, a whole hierarchy of activities. So, before, I've called these things heuristics. Heuristics are how people solve problems. So, what are those characteristics of human intelligence? Thinking, reasoning, understanding. There are a lot of things, for sure. Learning, is that an aspect of human intelligence? Please say yes. That's why we're here. And then there are lots of other things that maybe are not as exciting as those other ones, but they're certainly part of it, like memory, remembering, and computing. And I think somewhere, if we take a couple of those, we'd say, yeah, people can differentiate between poor and good instructions. Good. Now, just play along with me. Imagine that you believe that intelligence embodies these ideas and the ... dots mean more. Good. So let's ask ourselves the question. If the question is, can computers be intelligent? Let's just start now. But can we start at the bottom of the list and work our way up? Can computers do these things? Question, can computers compute? Yes. How well, by the way? Very well. Can computers compute better than people can compute? Yes. It's okay to say it. Yes. The processor in the mobile device that you carry around with you can easily multiply more than 100,000 numbers together in a second. I cannot do that. Computers can compute much better than people can. Can computers remember things? Yes. How well? Very well. Better than people? Yeah. We're all going to discover this next week, right? As we slap our head and look at your question on the exam, and why do we do this? You slap your head and you say, I remember that. When in actual fact, I don't remember that. That's why I'm slapping my head. By the way, hitting the hardware doesn't usually help. Okay. Yes, computers can compute. Computers can remember things. Computers can do many tasks better than people. Isn't that why we employ computers as tools for solving problems? Isn't it because of productivity and efficiency? Isn't it because they can compute much faster and better than we can? Yes, absolutely. You know, I forgot to bring the book. In the first unit of this class, I shared a quote from, this is Twilight Zone. The book was called Giant Brains or Machines That Think, published in 1949, even before I was born. Amazing. Wherein the author, one of the world's first computer scientists, argued that computers can think. Why did the author say that? Because he said, look, computers can compute, computers can remember things. That's exactly what we do. Therefore, they can think. Well, guess what? I think, no pun intended, that most people believe that intelligence has more attributes than just computing and remembering. So definitions are kind of important here. The moral of the story is this. If you can tell me what intelligence is, I can tell you whether or not computers can be intelligent. Can computers learn? Intelligent things have to learn. You're intelligent, you've learned. That has to be a characteristic of intelligence. Intelligent things learn. Can computers learn? If you've ever wondered why, answer, Luke.
With machine learning.
Even without it, they can. Yeah. If you've ever wondered, yeah, we were seeing machine learning last night. That was good. If you've ever wondered why computer scientists seem to be so enamored with game playing, and I don't mean Halo and Counter-Strike and whatever kinds of things you do today. I mean board games. Remember in war games when one of them asked, it was probably, why are those other games on there like tic-tac-toe and chess and checkers? Because they're games that teach basic strategy. Exactly. For years, computer scientists have been investigating learning in the context of game playing. In other words, can we get computers to learn? Can we? Yes. This is just a fact. Computers can learn to, for example, play better chess over time. They start off not so good, and after they play a lot, they get better. They decide what were the winning moves, what were the losing moves, and they develop their own strategy to do that. This is just a fact. Computers can learn. They can learn to play a better game over time. Your digital assistant learns the spelling of the different names, you know. My son-in-law is Jeff with a G, G-E-O-F-F. So I kept telling it, nope, do it with a G. It figured that out. It learned it. You bet. The computer is claiming its intelligence is real and ours is artificial. So Zeb and Martha had a scary time period. What? Anyway, Zeb had an aneurysm in the brain, and he needed a partial brain transplant. So, of course, Martha wanted the absolute best for Zeb. So she went down to the brain store, and she walked in, and the man was helping somebody else, so she just looked around a little bit. And she noticed there were a bunch of cases with brains in it. And the first case she got to said, movie star brains, $100 an ounce. And Martha thought, gosh, that's expensive, but I'll just look around. So then she wandered around. She came to another case, and it said, professional athlete brains, $500 an ounce. Martha said, a lot, but I want the best for Zeb, so I'll just look around. Finally, she came to this one lone case, and she looked in and it said, college professor brains, $10,000 per ounce. Martha said, gosh, that's a lot. Well, anyway, the person at the brain store was finally done helping the other customer. He came up to Martha and says, how may I help you? She explained the situation with Zeb, how he needed a partial brain transplant. And she said, I want the best for Zeb, and it looks like it would be these college professor brains, but why are they so expensive? And the man at the brain store said, do you know how many college professors have to die to get an ounce of brain? That's my best shot. Okay? All right. So, question. Can computers be intelligent? Let me give you my answer. I want you to have your own answer. You certainly know enough to be able to develop your own answer. But let me give you my answer. My reaction is yes. I am not 100% certain. I am 97.5% certain. I believe that computers can actually be intelligent. Now, first of all, they fool more than half the population anyway. Right? They appear intelligent, so maybe there's not a big difference between appearing intelligent and being intelligent. I can't tell about you. Are you just faking it? Now, hold on. There's a little bit more here. Let me take you on a trip down memory lane so you can see part of my reason for this. There's something interesting about people. People are wonderfully creative. If you lived 100 years ago when Zeb and Martha lived, would things have been different? You bet. Any new inventions over the last 100 years? Yeah. Let's go back 200 years. Go back 1,000 years. Human beings are wonderfully creative. I'm just not willing to bet against human creativity. Creating an intelligent machine, I believe, is possible. Let me illustrate this. Do you know who Bill Gates is? The founder, former chairperson, CEO of Microsoft Corporation. On most lists, he's the richest person on planet Earth. He wrote a book a number of years ago called The Road Ahead, and he tells this story. Now, I don't think this story is true, but many people think it is, and it's a cute story. Tells the story about the head of the patent office. The patent office is where people go with new ideas, new inventions, to get them protected. So Bill Gates says that the head of the United States Patent Office in the 1890s said, anybody ever hear this story? He said, let's close shop. Oops. Everything that could ever possibly be invented has already been invented. Anything new since 1890? Yeah, one or two things. Oh, by the way, you think 100 years from now, we're still going to be using iPods? No. I'm just not willing to bet against human creativity. All right. He's anti-creationist. He doesn't believe in Bill Gates. There's something funny about that. All right. Chuck Norris once built a robot with perfect human qualities. Fearing the possibility of not meeting Chuck's standard, it promptly disassembled itself. Boy, I sure hope Chuck never leaves us. Right? What will I do next semester? Hang in there, Chuck. Here's the second. So the first question was, can computers be intelligent? My reaction is yes. There's a second part of strong AI. There's another aspect. This is truly the transhumanism idea. Will you live on in the mind of a computer? Will we be able to capture the essence of you, transfer it into a machine, and then allow you to live forever? If you're wondering about the funny title, and I included this on the notes, I was looking for the earliest popular level account of strong AI research. This was an AP Wire story from 31 years ago that I'll be quoting to you. 1987. Will you live on in the mind of a computer? Now, here's a little newer one. Kurzweil, who is, I don't know, something at Google, right? We'll be uploading our entire minds to computers by 2045 and our bodies replaced by machines within 90 years. Just over 30 years, humans will be able to upload their entire minds to computers and become digitally immortal. An event called oh, come on. People throw out singularity. An event called singularity, according to a futurist from Google. The article that I have copied for you on the notes, if you're interested, focuses on this person, Professor Hans Moravec, director of the Mobile Robot Laboratory at Carnegie Mellon University. He is a computer scientist. Here's how that article begins. If you can survive beyond the next 50 years or so, you may not have to die at all, at least not entirely. That is one vision of the future being blah, 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 blah. Interesting. If you read that article, it's the same thing the current articles are saying. Hans Moravec says, we'll be able to transfer the contents of a person's mind into a powerful computer. In the process, make him, or at least his living essence, virtually immortal, Moravec claims. The things we are building are our children, the next generation. That article quotes a number of other computer scientists of the day. This was Gerald Sussman, who agreed that computerized immortality for people isn't very long from now. Transhumanism, strong AI, will you live on in the mind of a computer? So, here's the second part of the question, and I divide them in half. Many strong AI researchers just sort of put them together. I think it's important to divide them in half. So, question, will computers be human equivalent? Well, we did this already, right? We uncovered what the first step in problem solving was, and you told me it was to understand the problem. So just as before, if we have a word problem, I better understand the words. There's a key word in this question. The key word is not computer. It's not equivalent. It's not the transit form of the verb to be. The key word there is human. You cannot answer this question unless you can define for me what a human being is. Just as before, I couldn't answer the question of can computers be intelligent unless you tell me what intelligent is. If you can't define a human being for me, we cannot answer this question. Even in the headline, you saw that, right? Will you live on in the mind of a computer? The key word here is you. So, I guess it wasn't so far-fetched to define human beings before, was it? This is a central aspect of computer science. As I shared with you at the beginning of Unit 4, the answer to what's a you, that's not a scientific question. That's a worldview question. Different worldviews are going to answer this radically differently. The answer to what's a human being depends upon your worldview. So let's see that in this context. Oh, did you catch it? I told you the objective of strong AI research, but what's the goal? Why are they trying to do this? If you can survive beyond the next 50 years or so, you may not have to what? Die at all. And make him, or at least his living essence, virtually immortal. Yeah. The goal of strong AI is eternal life. Now, when I say that, sometimes people object. They say that sounds somewhat religious. I can't help it. Immortality, living forever in eternal life, those are all equivalent ideas, right? Absolutely. The goal of strong AI research is absolutely eternal life. That's where they're doing this. Kelsey?
So do they believe that people you'll actually know what's going on and be in the mind of the
Yep. Yeah, it'll be you and just your aged, I'll give you the quote in a second, your aging, decrepit body, this ain't you, this is me, right, will be replaced with robot parts. But yeah, you'll be cognizant, you'll be conscious, it will be you.
We won't have a soul.
Oh, that's an interesting comment. I think I'll run with that. Yeah, exactly. This is again a quote from that original article. Remember, this is 31 years old, 1987. You've been missing it, right? As you lose your natural brain capacity through aging, the computer takes over function by function, talks about training it to think like the brain. At the same time, the person's aging, decrepit body is replaced with robot parts. In the long run, Moravec says, there'll be nothing left of the original except for whatever that is, your consciousness. All right, what's the answer? Well, right now, I mean, we haven't achieved this. This hasn't happened yet. So it's speculation. But you're going to see that there are two radically different views depending upon two very different worldviews. Hans Moravec, Ray Kurzweil, and the others that I've quoted to you so far approach this from a humanistic worldview perspective. Humanism is based upon materialism and naturalism, and the thing that I'll just drive to is this. A humanist would say, hey, how did people get here originally? It was just a natural biological process. It was all material. Human beings are material only. What makes you you is the assemblage of neurons in your brain. Now think about that. If this is a true statement, if this is true, will you live on in the mind of a computer? Yes. If the only thing that makes us us is the pattern of neurons in our brain, we're going to be able to reproduce that. We're working on that right now. We're going to be able to reproduce that. If humans are material only, if that's a true statement, then strong AI is entirely possible. However, there's a problem. That's not a true statement. Sorry to be so blunt. That's not a true statement. Moravec in the article makes it very clear. Remember, he's a materialist, a naturalist, humanist. Natural evolution is finished. The human race is no longer procreating, but designing its successors. We owe our existence to organic evolution, but we owe it no loyalty. Yeah. If that's your worldview, then absolutely. Strong AI, you bet. It will happen. Now, allow me, if you don't mind, to share my worldview perspective with you. It happens to be the worldview of a number of you. It happens to be the worldview that Concordia University, Wisconsin espouses, a Christian worldview perspective. In a Christian worldview perspective, the ultimate origin of people wasn't a natural materialistic process. It was by direct creation from a superintelligence. So, yeah, thank you, Kelsey. Human beings, we have a body. We also have a soul. There is a non-material aspect to human beings that is just as important as our physical bodies. So, if this is true, and oh, by the way, it is, if this is a true understanding of a worldview and reality, then what's the answer to this question? Well, here's my answer. You may certainly have your own different answer. If you ask me, will you live on in the mind of a computer? My answer is no. God created human beings. And although I believe that we can actually look at his creation, like the human genome, and totally map it, we still haven't totally mapped it yet. Not only that, we don't have a clue. We don't have a clue of what 90% of the human genome does and is. Maybe we're not quite as smart as God. In addition to that, we have a soul or a spirit. The important thing to note there is how worldviews influence us. If you're a computer scientist that believes that human beings are just material, then sure, strong yeah, it makes perfect sense. If you're a computer science researcher like myself that believes human beings were created in God's image, then nope, I'm not going to waste my time looking at something that cannot be done. I hope you will indulge me and allow me to share something with you. The sad part of this story, Hans Moravec, Ray Kurzweil, Elon Musk, maybe some other names you've heard of, what they're searching for, eternal life, you know what? That's already freely available. Would you allow me to spend 5 minutes and share this with you? If you don't know this, I want to share with you the most important topic in CSC 150. This is the most important thing. I'm sorry, it happens in the last 7 minutes of the very last class. You know what the most, okay. Sometimes at this point in time, I'll ask students, what are you going to remember about this class 5 years from now? And since it's before the final, you know, okay, computer's a tool for solving problems, hardware, software, people, blah, blah, Zeb and Martha, Chuck, no. You know what you're going to remember about this course 5 years from now? That doesn't bother me at all. It's not the point. The point of this is not, let's fill my fact, what's this brain with 1,000,000 facts? The point is to develop some other skills and abilities, even without you knowing it, which you've done in homework. Okay? That doesn't bother me. But I want to share something with you. It relates to eternal life. And you know what? Eternal life is a little longer than 5 years from now. When Jesus, talking to one of the preeminent religious leaders of the day, somebody who should have known something about eternal life, Nicodemus went to him and said, I don't get it. What's happening here? God loved the world. He gave his one-of-a-kind Son. Whoever believes in him shall not perish, but have eternal life. Eternal life is not really something that human beings could ever possibly accomplish. It comes from God, God himself. Now, to understand Jesus' words here, you really have to go back to the origin. So I got to give you the history of the universe in 90 seconds. Are you ready? The Trinitarian God, God the Father, had an original idea. The idea was for a physical creation, a perfect universe. Did God have to create the universe? No. God was in a perfect relationship with himself. He didn't need to do anything. He did so out of love. Guess what happened? This perfect universe that God created, the people he created said, I don't want you to be God, I want to be God. And don't blame Adam and Eve, it would have been us too, right? So we rebelled. We said, forget it. God could have legitimately said, okay, go to hell. But he did not. Instead, the second person of the Trinity, the Son, had the power to implement a rescue plan. And this rescue plan doesn't depend upon anything that you do. It's already been accomplished. Eternal life is already freely available. How do we know that? Because the third person of the Trinity, the Spirit, has the energy to reconnect us to the Father. In other words, now we can interact with the universe and with God the way it was originally intended. If you don't know about eternal life, can I just ask you to do me a favor? Would you talk to somebody about it? It doesn't have to be me. There are lots of people on this campus. We have 2 fantastic campus pastors. We have a dozen excellent theology faculty. And I bet there's even another student that you know. I'm going to just encourage you, if you don't know about eternal life, would you ask about it? Because this is a little more important than the grade you're going to get in this class. It's a little more important than what you're doing 5 years from now. This is pretty important. By the way, This is the only true fact that I've shared with you about Chuck Norris throughout this class. You didn't know all those other ones were made up. But Chuck Norris is a fairly committed Christian. And you can't talk or read stuff from Chuck Norris without this coming through. So, if Chuck Norris accepts it, you know it's got to be true, right? So if you want to ask Chuck, you may do that also. Okay, here's my final bumper sticker. All right. So now you're wondering, do we have anything else to do in this class? Yeah, we do. So just keep coming. Monday, May 14th, 2018, 10 a.m. in this room here is our final exam. I've talked about the logistics of it. If you've forgotten, look online at Blackboard. Or do you have a question? I got one other thing to say after this. Do you have a question about the exam or what we're doing? Or all right, good. Finally, let me say thank you. Thank you for being here. Thanks for being part of CSC 150. When I hang out with other people at other computer science departments, most folks are surprised to discover that the chair of the computer science department teaches the first class. At most universities, they give adjuncts the first class. I think it's important, and I enjoy this too. So hopefully you've derived some benefit from it, but I appreciate you being here. And I would say if you're interested in more computer science, I would encourage you to investigate that. That you can talk to me about. Okay? May I be excused? My brain is full. I agree. Thanks for coming. Have a nice day. Have a great weekend. See you on Monday. Oh, I'm sorry. Thank you for mentioning that. Yes. Would you no, if you leave it on the desk, I might know who wrote it. Just throw it up on one of these on the way out. Okay? If you filled that out, just throw it up there on the way out. Thanks for reminding me, Luke.